So this particular lesson is going to be about using limits of continuous functions. So we'll do that part separate from doing limits of composition of discontinuous functions, which have like gaps or maybe in pieces and they are not connected. So in order to explain this one, I'd like you to notice here that we have an exponential stuck inside of Trinise. Do you remember arcsine, what we said it was? It's okay if you say no.
No.
Do you remember, Nathan?
What it represents?
Yeah,
It's
like
sine inverse.
Exactly. So on the button we have the sign -1, just because it's shorter, but it's misleading to have that -1 because it looks like an exponent when it's not. So let's start with the part that we are more familiar with, because exponentials, you should have studied how to sketch them in grade 11. Sine inverses are not part of the curriculum. That's why this is the part of AP, but I did a brief review earlier for those of you who'd never seen it before. So an exponential. Let's start very basic. I'm going to go with just an exponential base 0.5 to the power of x. One of you, tell me, growing or decaying? Decaying. So it's going to decay like this and touch at 1, because anything to power 0 is always 1. Then I'll switch the color to apply the transformations. If you recall from grade 11 or even in grade 12, when we apply transformations, we do stretches before shifts. So can someone tell me if there is any stretches and what type?
Vertical stretch by a factor of 2.
Very good. So we're going to apply a vertical stretch by a factor of 2, and I'll do it with a separate color and just do it right over top. So vertically by a factor of 2, so that means the 1 becomes a 2, but it still decays. And maybe my arm here is supposed to go down a little bit lower, who knows, but it's the shape that matters, okay? So far, so good?
Yes.
Then we apply what else is left?
Horizontal translations.
Shifts
To the left once.
to the left once and
Down 2.
okay, so I'm going to use a different color for that one. I'm going to take this point right here because I only have one point to deal with. You could be more accurate with a table, but this is just a really rough sketch. We're moving it, what did you say? To the left,
To the left
1 and
down 2 units.
down 2 units. So it will end up being right there. Now, if you recall also, I wasn't drawing it, but for the previous functions, there's still an asymptote that the functions are approaching. So because we're shifting down, there will be an asymptote where? At -2. So when I'm doing this graph, I'm going to do it a little bit more accurate like this, touching the point of the shift, which is here at -1, 0, and then it approaches the asymptote. Any questions so far from anyone? So we're going to use this little graph to help us answer the questions. For now, we just did the inner function. Let's call this inner function g, just like we did before. If you recall, we did it in the following way. We said as x approaches, Nathan, we have our original question. What is x approaching in our limit?
0 from the left side.
0 from the left side. We need to figure out what is g doing. So 0 from the left. I'm going to use, let's do a blue color. We're looking at the green graph because everything else was just intermediate. We're approaching 0, you said from the left. I'm going to move this arrow to the green graph. What number would it be down there? If you're not sure, we could just plug in 0 into the equation and see what happens. It is -1. My scale is really wonky, but that's okay. We'll just label it. Okay, so g is approaching -1, but don't stop here. Can you tell me, Nathan, is it approaching -1 from the top or from the bottom? Because that actually matters here.
From the top.
From the top. What sign do I put here? Minus or plus in the corner?
Plus.
Plus sign. Did anyone get lost so far? Okay, so now that you have this part, you're going to rewrite the next question. So the question becomes, so this original one is going to be limit as g is approaching this -1 from the right side. So from top becomes from the right because input became output now, or output became input. Venkat? because right after I do this with the plus sign, I'm going to drop it, and we'll discuss why if we drop the plus sign, that you might get stuck. Okay, so remind me if I forget to do that. So my next part, I'm replacing arc sine stays, but instead of everything on the inside, what did we call it?
G.
G. So it's arc sine of G. You could use brackets there if you wish, or just G. And if you don't like arc sine, feel free to record sine inverse of G, your choice. Okay, now we're going to repeat a little sketch of the sine inverse. I'm going to do it from scratch because off the top of my head, I don't know how this looks from beginning. I need to take my sine and do the inverse and then chop off the parts that don't make sense for it to be a function. So I'll repeat what I did before anyways. So if you recall, we would say sine wave. So let's do a black, just sine, not inverse, just regular sine. When we draw that sine wave, describe what I should be drawing.
It starts at the origin. So.
And then goes up like this, right? Like a wave. Right? And then we have certain points. This point would be negative pi over 2, negative 1, a 0, 0, and pi over 2, comma 1. I'm only going to be interested in this little chunk because if you recall, we want it to be a function once we do the swap of x and y. So that's the only part I'm going to keep. So now I'm going to draw with a red color sine inverse. So 0, 0 stays 0, 0. Then instead of pi over 2 first, we'll have 1 first, and then x and y get swapped. Am I going too fast, or is that okay?
No.
So that's 1, pi over 2, and then we'll have another point, a negative 1, down negative pi over 2. So just having 3 points, sometimes it's kind of hard to, how do we connect them? Do we connect them with a straight line? Yes or no? No, it's not supposed to be a straight line. Do we connect it in this way with a curvature going kind of flat at the center, or is it more like that? So if you drew it like this, it looks exactly like the original, doesn't it? In terms of curvature, should it look like the original?
No.
No, it's supposed to go like this. Okay. So that's our little wave for sine inverse. I'll label it. Okay, so now that we have a little picture to look at, our question is about G as the input. So feel free to call this input G now instead of X, whatever. It's just a dummy variable. And now we're approaching, Trinise, we have negative 1. What does the plus sign mean here?
You're approaching from the right.
From the right. So remember, when we were doing as an output, it was from the top, but now because it's a composition, one function is inside of another, and so now it becomes the input. So it now is the independent variable. So I'm going to say negative 1 from the right. So again, I'll use a little arrow.
I have a question.
Yes, go ahead.
Does the output only become the input when it's a composition function?
That's right. Yeah, input. Yeah, because you're composing one inside of the other. So output becomes the input. So everybody agree with that little arrow? I'm going to negative 1 from the right. I'm going to move this arrow to the graph. And what is my intended height of that?
Is he negative pi over 2, right?
Yes. And that's the end. So Venkat, now your question. If you were to forget about the plus sign, and at times if you forget it, it might not actually affect anything, but here it would. So imagine you did this and you said G approaches negative 1 without being specific that it goes from the top. Okay? So then this question will become, so this is what if, limit G approaches to negative 1 without plus or minus of sine inverse of negative, sine inverse has a negative 1 of G. So Venkat, if we don't have a plus or a minus, what does that mean in terms of limits? From both sides. Now, if I were to do it from both sides on our graph, I'm approaching negative 1 from both sides. Is there a graph on the bottom here that I could travel along from the left edge? No. So if this was the answer, though, you would say D and E as your final result. I mean, that could be the answer that it is D and E, but in this case, it's not, because it is truly one-sided in this situation. Did I answer that question? Oh, the question is why are we saying from the top? So pay attention to the arrow. Let me zoom in. So you know how we said we are approaching from, what was the question? It was x approaches 0 with a little minus sign. So here's my 0. I'm hovering over 0 with my mouse. I'm approaching 0 from the left. You see that arrow? Now you move it to the graph in question, which is our green graph. That arrow follows the graph in question. Do you see how it's pointing down towards the point of in question? So it's approaching from the top. If it was going upwards this way, so if we were doing it this way, we would say approaching from the bottom with a little minus sign. So just associate the plus sign with positive things, right? When you're thinking about number lines, positive numbers are on the top, negative numbers are on the bottom, and so you could use those plus and minuses accordingly. Same thing with left and right. Left numbers are negative. On the right is positive, so use plus and minus accordingly. Did I answer it now? Or still not clear? Okay, so the question I'll repeat for the video. The question is about this original one is from the left. So that's not a question for you. Why we're doing that? Because the question says so. That's not the issue. Why are we changing it from top to bottom? We have one function stuck inside of another. So I think it would be good to review when you have a composition. So G function is stuck inside of another function F. So X is considered the input of G. Then once you figure out what that value is, G of X, this whole thing is an output of G, but it becomes the input, what you were saying, right? Input of the outer function of F. And then you apply F to it and say F of G. And now that's the output of the F. So when we're talking about output, think of it as Y values. Y values. So that means either top, you could be approaching from the top, or you can be approaching from the bottom. But when you're talking about input, that's about x's. Does that help? And then x's could be left would be with the negative, and right would be with the positive. Does that help? Okay. Having one example may be not enough. Do you want to see another? Get more confident? Okay. So this one is different because I have still trig inverse, but instead of exponential, I stuck ln inside. What's ln? ln.
Natural log.
Natural log. So it's basically a log with a special constant e. So ln of x. And the special constant e, do you remember what number was?
2.1, no, 718, I think.
Very good. You have good memory. Okay. So once again, I'm going to call the inner function just the g function. And we need to figure out, as x is approaching 0 from the right side, we need to figure out where is g going. And it helps to see the graph. I'm a visual person. That's why I always keep drawing it. Plus, it's a good tool to be able to know what the functions look like, because it is helpful in the future as well. So based on that base, would this grow or decay as a log? Grow. So we're going to have a VA instead of HA, like exponential, and it will grow and still touch at 0. So this is the original ln x graph, which we actually don't have any more transformations. I don't need to do anything else with this. I can now use my arrows to indicate how I'm approaching. I'm approaching 0. What's the plus sign again? This one right here. X approaches 0. Is that from the top or is that from the right?
The right.
Because x is your independent variable, that's horizontal, right? So you would say I'm approaching 0 from the right. So draw the arrow. This is 0 being approached from the right. You move this arrow to the graph. Where are we going? Negative infinity. So I know we can't ever reach it, but we're going to use it because it actually is helpful for the next step. Any questions so far? It's okay? So now I'm going to rewrite the question. This is limit. What do I put on the bottom?
As G approaches negative infinity.
G approaches negative infinity. You would never be putting a plus or minus on infinity. You can't approach infinity from both sides, just one side anyways here. And of what? Limit of, what else do I put beside the limit? Look at the original question.
Oh, 10 inverse.
10 inverse. And what's inside?
Log x.
No, ln x we
Oh, G.
replaced with G. So we're now not in terms of x's, we're doing it in terms of this new letter G. So everything should be in terms of G. And now we just need to know what that looks like. So once again, we'll start with 10, and then we'll just do the flip of x and y to figure out what that looks like, yes? So we've done that before, but just in case for the video, if you're watching this maybe later and you forgot, this is 10 graph, and it keeps repeating. Do you guys remember where it has a VA? There's VA every time. Do you have any memory?
I don't know the exact points.
90 degrees in radians.
Pi over 2.
Yes, so each one of these is pi over 2, negative pi over 2, and the period of it is just pi. So halfway one way, halfway the other way. Again, we're going to just take the part in the center here, because it has to be a function once we do the flip. So when we do that, 10 inverse will look like this. 10 inverse will be, instead of vertical asymptotes, it will have horizontal ones at pi over 2 and negative pi over 2. And then it will do a switch. So think of this shape here, concave up. I know this terminology is new to us. Think of it as like cup up. So when you do an inverse, it will be cup down, like concave down. So when you're drawing this one, it will be concave down here. And then the other way, right? So it will cup up on the other side because the original was cup down. Okay, because it's kind of hard to tell how to twist it. So thinking about it like a cup up versus down maybe is helpful. Okay, so now that we have the picture, we're looking at this particular graph. Let's call it G inverse or 10 inverse of G. And G is approaching what? Remind me.
Negative infinity.
Negative infinity. So I'm approaching negative infinity on the x-axis here. Do you agree that's the arrow? That's negative infinity in that direction. You move this arrow to where the graph is. And what's the intended graph or value of that height? It's going to be approaching what height?
Negative pi over 2.
That's it. Now, it's approaching it from the top again, so you could say plus. So if this was another composition, let's say there was a third function, you have to stick this in, then you can continue that chain reaction. But because it's the final answer, it doesn't really matter how it's approaching it, because you just want to find the final answer. Yes?
In all of our questions, the limit is one-sided. So how would we do it if it's two-sided?
So if it was two-sided, it might end up being the D and E that we discussed over here from the question that was asked earlier. But you still have to justify why. Do we need another example, or is this enough? Because I do have one more set up, but I don't know if we need it.
Let's do that one.
Do you want to do the arcsecant? Because it's an inverse of a reciprocal of cosine. It's not that hard though. Okay, should we do it? Part of the recording in case you want to look at it in the future. Okay, so e to the x. Actually, let's start with e to the x, and then we'll do a different color for e to the negative x, the g function. So this would be our g. E is again that special number. It was 2.718 approximately to the x. So growing or decaying?
Growing.
Growing. So the red graph will grow again with a horizontal asymptote over here, touches at 1. What is this negative, where is my mouse? Right here. Do to this red graph?
Doesn't
The
reflect it.
inverse.
It's not the inverse, no. It's some sort of reflection. Is this horizontally reflecting or vertically reflecting?
Horizontal.
Yes, so it's reflection in the y-axis. So instead of growing, my black graph will decay. Yes?
Yeah.
Okay, so now, as x goes to negative infinity, what is g approaching?
Negative infinity.
Okay, we're looking at So I'll draw the arrow. X is approaching negative infinity. So that's my arrow. And I'm traveling on a black graph. Where is it going? Infinity. There we go. Okay, it's going up. You don't have to put a plus or minus here because it's already one-sided. We're good with that? Okay, so now our question becomes limit. What do I put underneath?
As G approaches infinity.
G goes to infinity of arc secant. And if you don't like arc secant, put secant with a little -1 of G. Your choice. Same thing, it's just a different way of recording it. So in order to do that one, we need a little picture to see visually what's happening. Ready for that one? I'm going to do it in 3 steps. I'll do cosine first in green. Then I will do the reciprocal of it in red. And then I will do in blue the secant inverse. Is that okay? So let me zoom in on it. So blue one or green one. Tell me what I should be drawing.
Starts at a maximum and goes down.
Yes. Okay, the red one. Do you guys remember what it does?
It uses like those turning points in a sense.
And creates little
Like
U
parabolas,
shapes, right?
Yeah.
So everywhere there was a 0, it became like a VA. Is this familiar?
Yeah.
And it does this bit. Right? Okay. The part that we'll end up keeping for cosine, we always kept obtuse angles. It was something like this for cosine. That means the corresponding ones that will pass the vertical line test once we flip it would be these two. So I'm going to do the blue graph separately because it's already too much on one graph, right? So we'll have, instead of vertical asymptotes, we'll get horizontal ones. And specifically, this is the one, pi over 2. Then this particular point is pi down -1. And this point is 0, 1. So I just need to swap them, right? 1, 0. That's one point. And the other point is -1 and pi. Right here. -1, pi. Okay, we need to approach asymptotes. This is where I get confused. I have to think about it. I want to approach an asymptote, but should I go that way? Should I cross the axis? Does my yellow region cross the axis?
No.
No, so I went the wrong way then. Must be going this way. Same thing here. I don't want to cross the axis to approach the asymptote, right? So just approach it here. There it is.
Wow.
It's a lot, but it's not that hard if you just do it one stage at a time. Just build from the knowledge you've seen before. We've seen inverses, just maybe not on that one, but it's not that much harder. So now that we have the blue graph, let's zoom out. What did we need to do? G is approaching what?
Infinity.
Okay, let's look. G is approaching infinity. That's over here. And I move it towards the graph. What is the intended height? It's reaching something.
Pi over 2.
There it is. Pi over 2. And it's doing it from the bottom. So if this was composed yet again into something else, you would use the fact that there's a little minus sign there. But again, because we're done, we don't have to do that part. 3 examples. I hope that's enough.
I think that's good.
You're welcome.